Let's talk about practice test 7. See how you did. Curtis is making a triangular frame. Curtis. I don't know why you'd make a triangular frame, but that's what Curtis is doing. Has a base of 12 feet. In the perpendicular distance, that's at a right angle, from the base of the frame to its vertex is 6 feet. We want to know the area of that frame. So let's just draw a quick drawing of what's going on. Let's sketch this out. So here we are, perpendicular, that means right angle. That's the height of the triangle. The base is 12. We're going to start with the formula. Area equals 1/2 base times height. On the test, you need to write the formula. If you don't write the formula, you will lose points, so get that down. 1/2, base is 12, height is 6. 1/2 of 12 is 6. 6 times 6 is 36. We need units in our answer. Squared, circled, and then circle it up there. If you were to say just circle C because you're lucky, you wouldn't get any points for this problem because you got to show work, got to show me how you got it. I'm not testing how lucky you are, I'm testing how much math you know. Question 2, we have these two figures and we want to know the area of the white part of the figure, the bigger square. So we have like a cutout there. And so what we have is we have figure A and figure B. And if I want to know what the white is, so A, by the way, A, I'm talking about this whole thing. And B is just the little guy. So if I want to know the white part of that, the area of A minus the area of B is what my area total is going to be, right? And the area of A, well, that's just base times height. Which is going to be x times x, or x squared, minus area of B. That's another base height. And I'm going to put a little a there and a little b there, just so I know they're different bases and heights. Minus 6 times 6 minus 36. And so here is our formula, x squared minus 36. Coming on over here, looks like it's going to be this one here, x squared minus 6 squared. 6 squared is 36. So 6 times 6 is 6 to the second power. So that's where that's all coming from. All right, we have this park that's the shape of course, a trapezoid. What else would you have for a park's shape? The shortest side of the park and its height have the same dimension. We got to first fill in the missing boxes, but then find the area of the park. Well, if this dimension, the up and down, is the same as the short side here, that means this must be 9. And then, of course, if I'm working through here, if this distance is 9, and this is 3, and this is 3, the whole thing must be 3 plus 9 is 12, plus 3 is 15 miles. All right, now we need to find the area of the park, and I have two triangles that are congruent to each other. We'll call those A, and we have the rectangle in the middle. And so we have here for the area of the triangles, the area of 2 times area A, because we have two groups of them, is 2 times 1/2 base height is 2 times 1/2. The base of that is 3. The height is 9. Now I did this for a certain reason. Usually I just find the area of the shape A and then I times it by 2. I threw the 2 in the original formula to account for both of them so that I could do this and not have to have fractional parts. And 3 times 9 is 27 miles squared. And I have one area B, so I'll just have one of those. That's base height is 9 times 9 is 81 miles squared. This is a big park. All right, it's like a national park or something. Now, I need to add those up, right? So the area total is my 2 area A's plus area B's, and I already found 2 area A's was 27, area B was 81. If I add that up, I get 108 miles squared, and I just circle that. And that's my answer. Oh, look at this. We have multiple choice. I can just circle an answer and get it right, right? No. No. We got to show all our work. We got to show our formulas. We got to calculate it and then look for the answer. So here we go. We have this parallelogram. And we know a parallelogram is base times height, which is the base is 10, right? And we know that the base and the height have to meet at a right angle. And so the height must be 5. Okay? And now, looking at my answer choices, it's as far as I need to go, right? Because their answer choices don't include units. They don't include a final answer. They just want to know how you would calculate it. And that looks like that matches that pretty well. So there we go. There's our answer. The 7, of course, that's nothing. That has nothing to do with calculating the area of that figure. It's just extra information just to fool you. Okay, so here we go. We got to plot this kite. Of course, all mirrors come in the shape of a kite. I think you all know that. So let's plot it first. So remember, what's up? What's up? What's up? Sideways and up and down. Or X comes before Y in the alphabet. So we're going to go over 2 and up 1. We're going to go over 1 and up 5. We're going to go over 2 and up 7. We're going to go over 3 and up 5. And that's it. And then we're going to connect the dots. And we have our kite-shaped mirror. Now, one thing to keep in mind, you have to be really careful about this. I even messed this up when I was making the answer key. Each grid line is 10 inches. All right, so if we have this distance right here, right, that's not 1, 2, 3, 4, 5, 6 units. That's 60 inches. And this is not 2 units, it's 20 inches. Be careful about that. That can get you. The next part is calculating the area of that mirror. And one thing I remember about my kites is that generally I can take this triangle and move it over here as long as I kind of rotate it, and I gotta flip it. Oh, flip, left, right, and it fits nicely right in there, right? So if I do that, that's no longer there. Well, I can do that with this one too. I can cut that out and put it right here. And what I end up with is a nice rectangle, right? A nice rectangle right there. And so now I'm going to calculate the area of the rectangle, which is base times height. And my base there is 10 units, right? Because the whole thing across was 20. But now I've moved things over, so I'm really only occupying 10. 10, and the height is still 60, is 600 inches squared. And of course, you circle your answer so teacher knows what you think is the answer. Okay, we have volume of a rectangular prism. Oh, I can draw one of those. Something like that. And it says it has a height of 6.5 meters. It has a length of 8.4 meters. And it has a width of 5 meters. And we want to know volume of that thing. And of course, volume is area of the base times the height, or length times width times height, which is 5 times 8 and 4/10 times 6 and 5/10. So I just got to do some math. It looks like 8 and 4/10 times 5 is 42. And multiplying 42 times 6 and 5/10, I get 273 cubic meters, meters to the third power, meters cubed. Circle your answer. Everything's there. It looks like a nice score to me. All right, now we're looking for surface area of this triangular prism. Start by drawing a net. I know it's extra work, but it's going to ensure that you get it right. So I'm going to start with the bottom, not the base. It's not the base, it's the bottom of that prism. Okay, and that is a rectangle that's 25 by 15. And then I have this front panel here, this front ramp-like panel That's 25 by 17, so that shares this side. 25 by 17. There's my 17. 25 overlaps. Then I'm going to go to the back and fold that down, and that shares the 25 side again, and it has an 8 side. And now I have my two triangles, okay? And the triangles have a height of 8, so I know it's going to share that 8 dimension, and of course the bottom is 15. So now I have these 4 different shapes, right? I have 2 triangles. I have 3 rectangles. They're all different. All right, now I have something to help me keep track of my work. Okay, my area total is, I have 2 area A's, plus area B, plus area C, plus area D. So let's do that one at a time. Area A is triangle, it's 1/2. Base height is 1/2. 15 times 8. Half of 8 is 4. And 4 times 15 is 60. Area B is 17 times 25. Oh, base height, need my formula. 17 times 25 is 425. Area C, calculating up here, is 375. And then we got to do area D still. All right, so let's see. We're going back to our original formula. I need 2 groups of 60 plus a 425 plus a 375 plus a 200. I add all that up. I get 1,120 square yards. Is that one of my choices? Please, please, please. Oh, it's C. Nice. Nice. Okay, but to get credit for this, of course, you have to show all this work. You can't just circle an answer. All right, now this one's kind of a look at it and figure it out. I suppose you could cut it out, try to glue it together, tape it together or something. But what I see here is I see all rectangular sides. So there's no way it's a pyramid. It doesn't have a single triangle in it. So that part is easy. So that's a prism. And they're all rectangles. So my goodness, it must be a rectangular prism because the base has to be a rectangle because that's all there are. All right. You could call it a square pyramid, I suppose, if you called the squares that, but rectangular covers the whole thing. All right, another surface area problem. We're going to draw the net. Start by drawing the base, which happens to be a square. There it is. Now we're going to do the lateral faces. They're all triangles. And they happen to be all the same. So I have a shape A and a shape B. I happen to have for my area, I'm going to need 4 A's and 1 B. So let's start with the area of shape A. That's 1/2. Base height is 1/2. 6 times 4, which is, half of 6 is 3. 3 times 4 is 12 meters squared. And then we have area B, which is just a square. Base height, which is 6 times 6, which is 36 meters squared. My area total is 4 area A's plus an area B, which is 4 times 12 plus 36, which is 48 plus 36, which is 84 meters squared. Circle my answer. Done. Okay, Heather wants to make a tray with sides that are 3 inches tall and a base that's 6 by 6. That sounds like a nice project. She has a thin piece of wood that she can use, and it's 12 by 12. She wants to know if she has all the pieces she needs to build this thing, if she has enough wood to build this thing. So this thing again is 3 high, and then it's a 6 by 6 base, and it's open at the top. So when we're drawing our net, we got to remember that we have a bottom and sides, but we don't have a top. So anyway, 6 by 6 square here, There it is. And then we have our sides on all four sides here. And they all have a measurement of 3 there. So I have 4 of shape A and 1 of shape B. So my area, let's see, area of A is base height is 3 times 6 is 18 units squared. And area of B is base height is 6 times 6 is 36 units squared. So my total area is 4 area A's plus an area B is 4 times 18 plus 36 is 72 plus 36 is, I believe that's 108 inches squared. Now the board, let's see if it has enough area. That's the first check. So the board, that area is base height is 12 times 12 is 144 inches squared. It seems like we have plenty of room. Just to, if you were actually building this, you'd have to actually map out on your board, on your 12 by 12 board, if all these pieces would fit on there, because if you had like a really skinny long board, it wouldn't work. But for the problem here, our math problem here, you just got to make sure that this area of what we want is less than the material that we have. So does she have enough wood? She has enough wood. Yay, Heather. Okay, and that's all there is to it. If you have any questions, don't understand something I did, please see me and we can go over it and get you in the right place. All right, take care.